this is a little bit kind of a different exponential type equation. So when we have ones like this, what we need to do is make the bases. What I mean by the bases are these guys. I need to make the bases match. And once the bases match, I can focus on the exponents. I have an equal sign. I know that the left side equals the right side. I already know this. So what I want to do is I want to make them equal the same base, so then I can focus on the exponents. So with this one, I can break down into 5 and 5. This guy can do 5 and 25, and then 5 and 5. So, ooh, they can break down all into 5s, can't they? So with 25, I can rewrite that as 5 squared, and it already has the x plus 2 here. I have to make sure I include that. That's already there. Equals, and this guy is going to be 5 cubed because there's 3 of them. So now I have the matching base here. So if I know they're equal to each other, I can say that these exponents are also equal to each other. So I have 2, and I'm going to stop with the color coding just because it's a little time consuming. I don't think it's necessarily relevant right this minute to keep color coding this piece. So now I know if the bases are 5 and 5, and again I have this equal sign, they have to equal each other. So I want to know, okay, well, what does x need to be in order for it to equal 3, since it has to equal this other side? So I'm going to go distribute this, and I'm going to 2x plus 4 equals 3. I'm going to subtract 4 from each side because now I can start solving. 2x equals, those guys canceled, sorry I didn't say it, but they canceled. 3 minus 4 is negative 1. Divided by 2, divided by 2. X has to equal negative 1/2 in order to make this true. So that's what x needs to be, is negative 1/2. All right. Okay, so I'm going to erase this stuff real quick. And the table of ordered pairs gives an exponential function. Write an equation for the function. So if you don't know how to do this, this would be a very good spot to kind of stop if you didn't have this in your notes pages, to go back and take a look and say, okay, well, what do they want me to do here? So this is, we're told that the table gives an exponential function, so we'll try to write its equation in the following form. So we need to know this form. And again, we should have this on our notes pages, where a is does not equal 0, and b has to be greater than 0, and b cannot be 1. So there's a couple of issues there, or not issues, but limitations. The number a is the y-intercept of the graph. So this number in front here, this is the y-intercept. From the table, we see that our function contains the point 0,9. So they told us that, 0,9 here. And this is the example problem. So the y-intercept is 9, which means that a equals 9. So right away from the table I can figure that out. So we're looking for, where does x equal 0? That's my y-intercept. And then we can go through and we choose another point. It doesn't matter which point we choose. We're going to choose any one of the other points, and we're going to plug in x and y. We kind of want to choose where x is 1. And the reason we want to do that is because x is the exponent. It makes it super easy if you choose 1 as an exponent, because it basically just kind of fades away. I don't have to take the square root of anything or the cube root or anything like that. So 1 is what we're kind of aiming for there. And then once we have that b term, once we've solved this, then we can go back and put our equation together, because we'll have our y-intercept and then we'll have the b that we just solved for. So let's go back in here and we're going to try this. So our y-intercept is 10. So ours is going to be 10. That's going to be our a, right? I'll say a equals just to have it. So we know what our a is. Now I'm going to choose one of these, and like I said, 1 for x is the ideal one that we want to choose. So my y is going to be 20 equals 10. We know that's a. And then b, we don't know b, but we do know x is going to be 1 because that's what I just chose. So everything is plugged in except for b. That's what we're plugging in real quick to find. So now I'm going to divide both sides by 10, and I get 2 equals b to the first power, or just b. So now I have my b term, and I can go back in and plug this in. So I have y equals 10 times 2 to the x power. And y and x go back to y and x when we write this in an equation. We only plugged those in so that we could figure out the missing piece there. So y equals 10 times, whoops, why did it do minus 10 times 2 to the x power. Alrighty.